Good morning, good afternoon, everyone, and thank you for joining our WebEx today. The topic today is Alian Crosstalk Explained and Measured. You might see a funny French expression below, exogenous crosstalk. Alian crosstalk in standards language has to be translated to French, and that's the French word for alien crosstalk, exogenous. My name is Wayne Allen, and I'm the Regional Marketing Engineer for the Asia Pacific region, and I am your host for this WebEx. So let's get started. One of the biggest questions we often get asked is just what is alien crosstalk? And in simplest terms, alien crosstalk is signal that gets into a cable of interest from another cable running close to the cable. If you look at the way we bundle cabling, we've got cables surrounded by cables. And if signal leaks from a cable into another cable, that's called alien crosstalk. The cable we're actually interested in is called the disturbed cable, or you'll often hear us use the term victim cable. The cable generating the signal or the noise is called the disturber. So what are the measurements we need to perform when we're doing alien crosstalk measurements? Well, the first one is called power sum alien next from, or power sum alien near end crosstalk loss. Power sum means the signal is coupled between multiple disturbing pairs and added together in simple terms. The measurement must be performed from both ends of the link for the disturbed or that victim cable. So we need to see how the cable is disturbed from both ends, because we need to remember if it's a longer cable run, there is attenuation in the cable that will attenuate the disturbing signal. The other measurement we perform is power sum attenuation to alien crosstalk ratio at the far end, PS AACR-F. And that's the difference in dB between the power sum alien far end crosstalk for multiple disturbing pairs of one or more channels, links, or components, as you can see there, and correlated to the insertion loss of the victim or disturbed pair in another channel, link, or component. Again, that measurement is performed from both ends of the link for the victim cable. You can do these measurements either using your channel testing results for certification or your permanent link certification test results. So what we're really saying here is you test all your links as normal, either using permanent link, which is the preferred method, or channel, and then we will use those measurements to calculate out, using another software package and some more measurements, the alien crosstalk that we need to take account of if there is any there. So how do we go about doing the installation testing? Where is the information on how to do this? Well, if we look to the TIA documents and we look at the 568C.2 and the new TIA 1152A field testing document, that's our starting point for how to make the measurements. And it should be noted that 568-C.2 is in the process of being updated to 568.2-D, D series documents. And that's in draft format at the moment with the TIA people. One thing people need to realize when they're doing testing is that there's no text stating that power sum Alian near-end crosstalk or power sum AACR-F testing is optional. There's no words in the document, in the testing documents, to say that is optional. So you've got to assume that you are really supposed to be doing those measurements when you are testing Cat 6a and Cat 8 installed solutions. And it doesn't matter if it's UTP for Cat 6 or shielded for Cat 6a. That's Cat 6a unshielded or Cat 6a shielded. You are supposed to test for Alian crosstalk. All Category 8 cabling is screened and still requires Alian crosstalk testing. The values that you are looking for and the methodology for making those measurements can be found in the TIA 568 documents or the TIA 1152A field testing document. Now with ISO and IEC, they've taken a slightly different approach. So there's your ISO 11801, which is your base document, and IEC 61935-1 is your field testing document. Power sum next, and power sum AACR-F is normative for field testing. Normative means it has to be carried out. Where you find that is in Annex A. So in 11801 Annex A, it is normative, and we normally do a sampled measurement. But very importantly in the ISO documentation, it says if not met by design. So if your OEM vendor says it's met by design, there is no requirement for Alian crosstalk testing. Now, there is some values shown in the documents, and basically if your coupling attenuation meets or exceeds values given in table 73 of 11801-1, the power sum Alian next limits are met by design. Again, in the same document, same table, the power sum AACR-F limits are met by design for length ratios of disturbed and disturbing links from links that are 1:1 to 15:1 in measurement. One thing to point out though is in the field you do not know what the coupling attenuation is. This is not a field test, so it's fairly hard to work that out. So have we met the limits on the table in 11801-1? You don't know from a field test, so you've got to rely on your vendor, or if you're not certain, you have to test. Now, we often get questions, well, this is a shielded solution. They should perform better than unshielded cabling as far as signal from outside the cable getting into the cable. But the proviso there is if the shielding is installed correctly. And as you can see in the first screenshot here from the Alian crosstalk analysis software, you can see shields have been terminated correctly, and there is no sign of noise at all. You have no waveforms there at all within the screen. If we now disturb the shield termination, in other words, we don't terminate it correctly, you can clearly see the difference. And if you take a very close look over here, you can see very closely in here and here, we're actually touching the limit line for the test. So individual tests are now actually failing. However, we have to do an averaged measurement, and the overall average, which is the red line down the bottom, our results are not touching that line, so overall we're allowed to give this a pass. But as you can see, it's a very near thing. Both links passed in this case when we did in-channel measurement, the TIA Cat6a permanent link requirements with good margin. And the same will hold true for ISO class EA permanent link testing. They will have good margin for in-channel testing, which is the normal certification testing that we perform in the field. But you must pay very close attention to shielding. And as you'll see a little bit later, with category 8 cabling, this is even more critical. So if we have a look at some of the new testing documents, and for published documents at the moment, let's look at the TIA 1152A document for category 6A and for category 8 in particular. Both Alian crosstalk measurements are a requirement. We stated that earlier. We also just saw that for this to work effectively, your shields must be correctly terminated. Now, when we look at Alian crosstalk in a laboratory type situation, we perform a measurement which is we often refer to as 6 around 1, where we put 6 cables around a victim cable and measure the effects. So we've done this in our lab, and this is for category 8 cabling. So power some Alian next with 6 around 1 with correctly terminated shields. As you can see from the test result here, it's a pass, and we've got quite acceptable margin there above the red pass-fail line, as you can see. So what we then did was drop a shield, and what we've done is we've made the same test with the same cables, but this time we've made the shield on the victim cable open circuit. And as you can see from the test result, with just that shield not terminated correctly, we've gone to quite an acceptable level of pass to now failing the Alian crosstalk measurement, the power sum Alian near-end crosstalk. So what we then did in our lab is further disable some shielding, and not only have we disabled the shield on the victim circuit, victim link, we've also opened or poorly terminated the shield on one of the disturber links. And as you can see here, the measurement result has markedly deteriorated. And this is still for shielded cable. This is category 8 shielded cable. So as you can see, shielding is highly important with these newer forms of cabling systems, especially as we move to high-speed data on category 8, which is capable of transmitting 25 gigabits or 40 gigabits per second. And this sort of then also shows the importance of those shields to keep noise out of those cables. So what are we doing in the field when we make these particular measurements? So there are 16 measurements that we have to make between the victim cable and the disturber cable. And as you can see here on the graphic, we're looking at each pair in the victim and then looking at all the other pairs and their influence in the disturber cables. And so you've got quite a lot of measurements going on there. And if you've got 6 cables around one, we've got to do this over 6 times. So it's quite an extensive set of measurements that we are performing when we do this in the field. Now for field testing, the power sum Alian near-end crosstalk measurement is quite simple to do if you set yourself up correctly. And here's a diagram of the actual test setup. First step, you test every link 100% for in-channel certification. So every link has to be 100% certified. For the links that you are going to be testing, and we'll deal with how do you pick a victim link shortly, what we're going to do is with our DSX 5000 or our DSX 8000 cable analyzer, the remote will act as a signal generator. So it will provide the signal to the disturber. Our main unit will act as the receiver. So it's attached to the victim cable, and it will be measuring how much signal is coupled between the disturber link to the disturbed or victim link. Testing is controlled by our Alian Crosstalk software package running on a PC, and that controls the main unit via a USB connection, as you can see there on the left. On the end of the links, we place a terminator, a 100-ohm terminator, to terminate the link correctly, just as if it was plugged into active equipment. So what do we actually need to look at when we do testing? Reality, most of the Alian crosstalk is going to come from the connectors. So it makes practical sense to pick links that are surrounded by connectors to ensure the worst case scenario. So if we have a look at this particular patch panel, if we took the connectors in the corners there, they would not be good choices for a disturbed or victim link. The reason for that is the adjacent connectors have a gap between them. There's a chunk of metal in this particular case between them. So they are well separated away. If we look at the top corners, no adjacent connector. So there's no adjacent connector at the ends there. So they're not a good choice for a disturbed or victim link. So what do we look for if we're trying to work out which link is going to be the victim link? Let's take this same patch panel and let's go here. It's a 24-port patch panel. As you can see, highlighted in green in there is a connector. It has connectors to the left and the right, and there are connectors, of course, above and below. So that's a good choice. What we even have to remember is when we're looking at it, and as you can see here, we're using the ISO evaluation. Bundle size for this particular job was 12 cables. So we would dress the cables from the 24 ports, 12 to each side. So if we're choosing this particular connector as a victim, there are 12 cables in the bundle, so we would then need to look at the other 11 links in that bundle as our disturbers. So we have all the links in the same bundle, or the most consistently positioned relative to the disturbed link as the disturbing links. And they're highlighted in blue there. Those that occupy adjacent positions to the left, right, above and below also have to be considered. So if we plug that into the equation, we have cables above and below. So if we were going to Alian this particular installation, we have 11 plus 6, we have 17 disturbers to consider against this victim cable. Now what you will find if you're using the ISO approach is they also allow sampling, and that's why it says in the document, normative sampled. And the standard they quote for choosing the number of links is the quality document, which is ISO 14763-2. And as you can see there, if you've got, as the table shows, from 150 to 3,200 links in your installation, you really only need to consider 33 links and test for 33 links. Even right out to 35,000 to 150,000 links, you're only looking at doing 201 Alian Crosstalk links for testing. So this is not onerous compared to having to do 100% Alian Crosstalk testing. And to that point, for many consultants, don't specify 100% Alian Crosstalk testing. Each Alian Crosstalk test takes about 20 seconds to do. And then it's got to be done from either end of the cable. And if you've got many thousands of cables and you work out the time, it's an enormous amount of testing over many months. So if you are the consultant or if you're looking at a consultant's brief, our best advice is to use a sampling approach when you have to do Alian Crosstalk testing. Now there's some guidelines there. You need an equal selection of short, medium and long links. The process that's used here is equivalent to acceptance quality level of 0.4% of normal inspection. And that's defined in ISO 2859-1 for populations of up to 500,000 links. And I personally have never seen a job with 500,000 links involved. So this is some fairly important guidelines for Alian Crosstalk testing. And there's some further guidelines, and Fluke Networks has also developed some recommendations. So let's have a look at those. Fluke Networks recommendations. So if you're going to comply with the IEEE 10G-based requirements, Technical Services Bulletin 155 from TIA or ISO Technical Report 24750, you select as the victim link the longest 1% of all links, and it should be 6 links at a minimum. The longer the link, the more susceptible it's going to be. As a disturber, and we follow the IC recommendations, all links in the same cable bundle as the disturbed links. All links with patch panel connections adjacent to the connections for the disturbed links should be considered. So if you remember the early graphic, we had one connection in the middle. Therefore, we had to consider the other 11 cables in the bundle, the 3 connections above and the 3 connections below. When you're doing the testing, you test the longest disturbed link or victim link first. Then do the tests on the other links in the sequence of descending length. When a test gives you a minimum of 5 dB margin, it is then not necessary to do tests on the other disturbed links. And then it should not be necessary to do tests on medium length and short length links because you've eliminated the possibility of alien crosstalk being there. When you are testing category 6A or class EA, use the AAC recommendation. That's the best advice we can actually give you. Often we get asked, what do I need to do this testing? So let's have a look at that. You're going to need a field tester. So you're going to need a DSX 8000 or a DSX 5000 from Fluke Networks. You're most likely going to need some patch cords to use as communication channel between the testers. As you'll see when we do the measurements, sometimes we need to interface with a cable that's located in the same area but not involved with the measurements. If you're doing alien crosstalk using permanent link test results, you need the appropriate permanent link leads. If you did your testing using the channel methodology, you are going to need the appropriate patch cords for channel testing. You'll need some Alian near-end crosstalk terminators, and these are normally provided with the DSX 8000, or you can obtain those for a DSX 5000. You need your in-channel test results, permanent link or channel, and these will be in Fluke Networks linkware PC format. You'll often hear us refer to it as .flw files. And your software needs to be the latest release. So your linkware software needs to be the latest. Your Alian crosstalk analyzer software needs to be the latest. And you need the latest firmware in your field tester. You install the Alian crosstalk analyzer software on your PC, and you will need the USB cable that came supplied with your tester, because the PC will need to control the main unit when making the measurements. So let's look at the practical part of doing the Alian crosstalk measurements. So here is the software. It's all ready to go. We're doing PowerSum Alian Next from end 1, as you can see from the graphic there. If I bring my laser pointer up, we're doing PowerSum Alian Next, and we're doing it from end 1. So the first thing, click on File and select New, and then you select the Fluke linkware file for the completed in-channel testing, and that'll either be your permanent link certification results or your channel certification results. And the software package will actually prompt you on what you need to do. So just follow along with the prompts the software package provides. So once you've done that, it'll open up your result file and present you with the different links. So here, this is where you select the link that you're going that is going to be used as the victim. And if you remember the patch panel, we chose that cable towards the middle of the patch panel. So that victim will correspond to what we selected when we looked at the patch panel. If you then press next, you'll be asked to select the disturbers to be used. So you will then locate the disturbing cables that you identified earlier as being the most likely ones that will cause alien crosstalk. And then by clicking next, you start with the PowerSum Alien Next tests on the longest link. So when you hit next, the software package will come up and show you a diagram of how to connect the testers and how to connect to the link. As you can see there, the field testers are to the left, connected with a communications link. Leads, permanent link leads or channel patch cords to the victim and the disturber, and attenuators are on the right-hand side there at the far end of the link. So as you move from disturber to disturber, you follow the prompts provided by the Alien Crosstalk analysis software. And as you do the measurements, you will see building up on the screen, and you can just see it peeping out from behind the guidance there, the results building up on the graphic. Once you have done all the testing, the package will decide on whether the testing passed or failed. And it's important to remember you can fail one test, but if the average tests say pass, you're quite okay. The installation meets the requirements for Alien Crosstalk testing. And it's just simple, as you can see there. Next, running the test. Select the next disturber, run the test. Select the next disturber, run the test. So let's have a look at how that evolves in real world. So here's my patch panel. I've got my software running. My software on the laptop is controlling my field tester. I have a DSX8000 sitting there. The DSX8000 is connected to that victim link, as you can see. And I'm starting with the adjacent connectors above. On the far side, you can see I have my terminators in place. So I do my test. Once I've got my result, I move on to the next disturber. So I move on and I measure the next disturber. Once completed, move on, measure the next disturber. Move on. So we've now got a little bit of noise starting to creep in. So we are seeing a little bit of alien crosstalk, but it's well above the limit. Now we're in the bundle. So this is the first cable of the bundle. Second cable of the bundle. Third, fourth, fifth, sixth. As we get closer in, as you just saw there, the connectors at either side, they're the ones generating quite a lot of crosstalk. So the last three measurements are down the bottom. So if we move through here, that's all the cables in the bundle. Then we go to the adjacent connectors below. Same process. Run the field tests, and we're complete. And as you can see on the software package, it says pass. Just peeping out there behind the patch panel, we have our pass there where I have the pointer. And as you can see, we are above the limit lines right along here. So our PowerSum Alien near-end crosstalk measurements have now been completed. Now it's time to move on to power sum Alian attenuation crosstalk ratio at the far end. But remember, the power sum ANEXT has to be done from both ends of the link, N1 and N2. So once you've completed from N1, the tester and the remote swaps to the far end, the terminators swap to the near end, and we repeat the measurement. For power sum Alian attenuation to crosstalk ratio far end, the remote still acts as a signal generator, but you'll notice in the diagram it's been moved to the far end. The main still acts as a receiver. Communication patch cord tells the remote when to generate the signal. Now, this can be another link located away from the disturbers. You use patch cords to patch into another link that acts as that communications channel. Again, the Alian crosstalk software running on the PC will control the main unit via the USB connection to carry out the measurements. So again, we now move to doing the measurements, and as you can see here, I've now changed. I'm now selecting the AACR-F measurement, and I'm starting at N1. Same process, but because we've already got the file and everything selected, our starting point's a little bit different. So we've selected the measurements we need to provide. Now to start the test, there's a right arrow up there in the menu bar. We click on the right arrow, that initiates the test. When the test initiates, very similar to what you saw before, you'll get a screen up where you select the disturber link, then select next. When you selected next, it will show you what you need to do. So again, the package has got wizards built in that will guide you through the measurement process. So now we select next. We follow the instructions giving the pop-up and then select next. So as you move from disturber to disturber following the prompts provided by the crosstalk analysis software, again, you will see the testing results appearing within the package. When all the disturbers have been used, and the package will decide on whether the testing passed or failed, just like it did with power sum Alian next. Again, you can have one fail in there, but as long as your average testing says pass, you're going to be okay. But you're still not finished. You need to remember you've got to do that measurement from N2 as well. So let's have a look at that from a practical point of view. Here is our power sum Alian attenuation to crosstalk ratio far end measurement. We have our DSX8000 near end. As you can see, we have our permanent lead connected to our victim link. Our DSX8000 remote is at the far end, connected to the first disturber. You can see the communications patch cords there. We've selected a link that's well out of the bounds of possibly interfering with our measurement. And we have our terminators plugged in at the respective points, one at the far end, one at the near end. And the measurement process proceeds as it did last time. We're moving the tester around, but at this time at the far end, we're moving our signal generator, which is our remote, and we repeat the same process. And as you move along, you can see the Alian crosstalk measurements forming up there. Again, most of the issue is around the adjacent connectors in the same bundle. And we'll move to the adjacent connectors below. So once we've got to a finish here, what you will see the software package do is it will issue the pass, but you'll also be able to rank the disturbers. So as we finish the measurement, what you'll be able to generate is a disturber ranking. So from that disturber ranking, you can see, and I've got the disturber ranking from the measurements we just performed here, that the majority of the Alian crosstalk in our victim cable, which is highlighted in green there, was coming from the two adjacent connectors of links in the same bundle. We had a small amount of Alian crosstalk in other cables of the same bundle and from the connector directly below our victim link connector, but a very small contribution, very, very small. So the majority of the contribution was coming from either side of our victim link. And then that would suggest to us that most of the Alian crosstalk was a result of the patch panel rather than the cables themselves. Now, if you are testing according to IEC 61935-1, which is the ISO field test document, they've got a couple of get out clauses. So if the margin for PowerSum ANEXT and PowerSum AACR-F has reached 5 dB for the links with the highest insertion loss, further crosstalk testing of links with the highest insertion loss can be discontinued when the number of disturbed or measured links is 3. So if you've done 3 lots of measurement and you've met the requirement, you can discontinue for those high insertion loss links. We then moved to the lowest insertion loss links, perform the same evaluation, and if you meet the 5 dB number, you can discontinue testing. And then we move to the links with a medium level of insertion loss, perform the same evaluation at least 3 times, and if you've reached the 5 dB, you can discontinue testing. So quite conceivably with your sampled approach, once you start testing, you find that you are actually not measuring any Alian crosstalk. You can start to stop those tests and further limit the amount of testing that you need to perform. So Alian crosstalk measurement is not a difficult subject if you know how to do it correctly. The point is you measure all the in-channel results to certify the link first, then select your victims, select the disturbers that you need to test against that victim, and then using Fluke Networks Alian Crosstalk software package, following the prompts, work your way through Alian Crosstalk testing. Now remember, just because the solution is shielded, that does not mean you do not have to perform Alian Crosstalk testing. You do have to perform Alian Crosstalk testing for shielded and unshielded Category 6A solutions or Class EA, and for all Category 8 solutions, which are shielded solutions. We need to know that the shields are working correctly. So that brings me to the end of our presentation today. If there are any questions, you are welcome to submit those questions. We'll try our best to answer those questions for you. Or if you don't want to ask questions here on this forum, please feel free to email us and we will provide individual answers back to you. So if there are no more questions, I'd like to bid you good day and thank you for your participation in this webinar. Good afternoon or good morning, wherever you are today.